Thank you very much for everyone for attending the seminar. So some time ago, I kind of volunteered to give a talk. I would like to talk about my paper and possibly get a feedback. And I was asked, as Paul mentioned, to talk a little bit about the process of trying to publish at this ABS 4-level journals. And I will spend a few minutes. So I don't see myself as very accomplished in that. So I just want to talk a little bit about my own experience and what I think it is. Probably there are even better people at the department to talk about it. And so just to give a background about this paper, this is a second attempt of a paper to publish at JAMS, Journal of Academy of Marketing Science. The first one published 2024 or late 2023. And this is a paper that is under review. Now, technically is in the first round of review, R&R, but in reality is fourth or fifth round because there was a one level of reject and resubmit somewhere in the middle. So it was R2 and there was a reject and resubmit, and I had to go back again. And so it's kind of fourth or fifth time that this paper is being reviewed at Journal of Academy of Marketing Science. So, and at this journal, like most of the journals, you get basically most of the top journals, you get 3 reviewers. So, and I think it's the same norm at JM, JMR. IJRM usually get 2 or 3, sometimes 2, sometimes 3, and management science and marketing science and JCR, these are marketing, usually 3 reviewers. So, and now when I was doing long time ago, doing my PhD, we had a very accomplished, well-published professor, and basically what he mentioned in one of the main seminars on how to publish a paper in top journals is that said you need 3 elements, right? So, and most of you probably well know that to get a paper published in a top journal, the first one, strong theory and strong theoretical contribution, right? So that's one thing. And second, robust methods and robust data. And basically what I'm talking about is mostly about empirical quantitative research, right? So I don't claim to know much about other ways of research, qualitative and so on. So what I say is my experience with empirical quantitative research. So robust methods and longitudinal data, and finally, high policy relevance and practical implications. So, and at that time, he told us that we need at least 2 of these to be fantastically well done to get it published. The third one could be average and so on. But since what my experience is that effectively when you get 3 reviewers at this top journals, you have to have all 3 of these. So basically, strong theories, strong theoretical contribution, robust methods and longitudinal data, and high policy relevance and practical implications. Now, and usually these 3 reviewers, every one of them is very well versed in one of these, and usually each one is very well versed in 2 of these, and you can see from the comments that there's no way around it. So everything has to be perfect in these 3 domains. Now, what I am mostly, I don't consider myself very theoretically strong person, but when I try to write a paper, I start with theoretical contribution. So to get that basically right, and then move into the next parts, which is robust methods and longitudinal, robust data and policy relevance. So that's one thing that I won't spend much time. The second basically and third things that are highly relevant is that when you have robust methods and you have basically when you are doing empirical research, quantitative empirical research, you need longitudinal data. And that in itself means that you can effectively look at the causal inference, which basically is the backbone of having policy relevance and practical implications. So if you don't have robust methods and robust longitudinal data in you now, depending on what data you're working in, you can't infer causality, and basically you can't make policy relevant implications, whether for managers, whether for policymakers, or even customers or consumers, any stakeholder. So in an empirical quantitative method, two of them basically become one thing, which is the causal inference. Okay, now that's the thing. And you can see from this blurb here that this is in longitudinal data, used different type of methodologies, basically try to address causality issues that we talk in econometrics, basically we refer to as endogeneity. Now this paper, I put the presentation paying to stay or paying to leave, rethinking compensation strategies amid competitive attrition. The paper is currently under review called When Winners Walk, How Compensation Dispersion and Regional Talent Density Shape Sales Talent Turnover and Competitive Attrition. Now, so when I say causal inference, basically this is what I mean. So marketing research often reveals correlation between variables. And this is what I often see with a lot of papers that I review, or from papers that I read from PhD students or their thesis and so on, is that causal inference, often the papers that I reject or they get rejected, is not at the core of the paper. So it's essentially, you have to determine whether there is a causal relationship between two factors. And for that, when you are doing empirical research, empirical quantitative research, you have to think about endogeneity long and hard. So, and basically whether you have omitted variable bias, reverse causality, self-selection bias, etc., etc. And firms need to know if, for example, a price cut, advertising campaign, or loyalty program causes increase in sales. You can't just show some level of correlation and say, well, we have a paper here and we have a implication. Basically, policy implication without causal inference is not accepted at this level. And if a paper, or if a paper that is being written and the idea of causal inference is not at the core of it to start with, usually it fails to get published at the later stages. And that's basically my experience with other papers that I have not published, or I haven't been able to publish at an ABS 4-star level journal. So, and the causal inference, basically what data you need is that what I see from a lot of editors, when you are doing empirical research, survey data doesn't cut it. At least survey data, one wave of survey data doesn't cut it, because you can't establish, you can't rule out reverse causality, etc., etc. At least 2 or 3 waves of survey, it's needed. Now, that's why it takes people like me, and many of you know how difficult it is to get response to one round of survey, let alone multiple rounds from the same subjects, to work on data that is basically secondary data and panel data. And that helps us to do not randomized controlled trials, because randomized controlled trials is not what empirical modelers do. We do methods like instrumental variables, diff-in-diff methods, propensity score matching, or SAM matching, which is quotient exact matching, control for confounders, or regression discontinuities design, so leveraging cutoffs based on assignments of subjects to different domain. So, and that's my experience now. And through these multiple rounds of review in this journal, I have been basically through, except for randomized controlled trials, which doesn't work with observational data, all 4 of these I have been through. So I have done diff in diff in one way, instrumental variable, propensity score matching. I haven't done propensity score matching, but SEM matching, regression discontinuities, and everything within one paper. And by the way, this paper is a solo author paper, so everything I have done is alone. So I'm not going to, I may come back to this, what I mean by those, but just to lay out the importance of this study of sales turnover and competitive attrition. So why do we study Salesforce? Simply high turnover rate. Salesforce has 25 to 35% turnover rate, and it's usually on average 3 times more than other occupations. And that means like every 3 years, your entire sales team would have changed. Costly replacement, each salesperson turnover cost for a firm, and this is B2B sales, around $100,000 to replace. Revenue and productivity loss, even small attrition increases. So if your attrition increases from 5 to 20%, it will reduce revenue by 20%. Long replacement cycles, it takes up to 60 days to fill the vacancy and 3 to 4 months to get these people up to the speed to work. Now, on the other side, when you are losing a salesperson, they leave, they might actually leave and join a competitor rather than just going a random company. And that means you have a double jeopardy, right? So you're not only losing revenue because you have lost a salesperson, you can lose a salesperson to a competitor, which means that they erode competitive advantage. So they can take clients with them, it erodes profit margin, it can reduce the market share. And what is not really understood much is about that limited understanding of competitive moves, which is what drives salespeople, especially top performers, to a competitor. We don't know much about it. We know the effects, the negative effects, but we don't know what drives them, what are the antecedents of this competitive attrition. Now, on the other side is the compensation research, right? Structure, and usually what we study in compensation, we have 2 aspects, which is whether it's compensation level, how much you compensate salespeople, or how do you compensate them in terms of structure, how much variable, how much fixed pay, bonuses, etc., etc. Now, the compensation research has 2 sides of it, to the compensation issue. First one is that it motivates people to work harder, to align their goals with the company. If you're paying based on bonuses, etc., which means that you're trying to solve an agency issue when it comes to incentivizing salespeople to work on behalf of the company. But the flip side of compensation is the turnover, right? So we know from HR research that pay structure has an effect on people's propensity to stay or leave. So, and all these compensation systems based on bonuses and variable pay, and etc., usually leads to a compensation dispersion between the top performers and middle and low performers. Now, here I call them core performers, the middle performers. So whether it's tailored or uniform for everyone, there will be creating compensation dispersion, and it will affect the turnover, which is less studied. So the research gap is basically looking at the interplay between compensation and turnover. So these studies explore compensation performance and performance turnover, but lack the integration. So what I am trying to understand is that different levels of performance, how they react to compensation and how they how it affects their mobility, right? So it's kind of at the intersection of performance level, compensation, and turnover or mobility. So, and on top of the turnover is the competitive attrition that hasn't been really studied. So, and basically based on that, I argue that compensation structures leads to compensation dispersion, which we don't know how it affects people's mobility in sales organization. Second is that what affects the company's ability to retain or maybe the turnover of salespeople is the availability of labor force within the catchment area, or basically the region that the company is trying to recruit. So, and the research question is that how do regional occupational concentration, which we call ROC, and compensation dispersion, which we call CD, shape turnover and competitive moves? So now, basically what I'm trying to do is that to understand the top performers turnover dynamics. And why do I only look at top performers? Now, I can't look at top performers because I don't have variation within them. So I'm comparing the top performers to core performers, and I'm leaving out the low performers. And the reason is that the mechanisms and theories that explain the mobility of lower performers are distinct from the mobility of the top performers or core performers, because often the lower performers, their mobility is involuntary turnover, and it's a termination case. But at the top, at middle to top, it's usually voluntary turnover at sales, and we can theorize about them differently. And I'm going to use expected utility theory, human capital theory, and principles of compensation structure within sales research to explain and motivate my hypotheses. So basically, the first hypothesis is that how do the top performers' mobility out of organization compare to core performers, right? And the hypothesis is top performer salespeople are more likely to leave the organization compared to core performers, explained by expected utility theory. Now, much of the theories that have been used in sales turnover research, they have looked at the internal effects of equity theory and expectancy theory. So, and the suggested top performers stay when they perceive fair rewards. However, the external options are also important, which expected utility theory helps us to understand. And based on that, we can say that top performance salespeople, so expected utility theory has two elements. One is P, which is the probability of receiving an offer, and U, which is the utility of each offer. And it compares the P multiplied by U, which is the external offers, P multiplied by U, which is the expectancy of receiving an offer with certain utility compared to the utility that you have internally within your current job. And usually it means that compared to core performers, high performers, because of their superior skills, enhanced visibility, they have higher expectancy because they are more likely to receive a better offer with better utility. So, and that increases their likelihood to leave the organization compared to core performance. Now, second hypothesis is about the moderation of CD, which is compensation dispersion. And basically it's the gap between top and low performers, which significantly impacts turnover pattern. In organizations with higher CD, top performers receive substantially greater rewards relative to their peers, which are the core performers, right? So there is a dispersion in the pay structure, and you can reach the higher levels of that pay, which effectively increases the utility, your internal utility within the focal employee relative to the external utility for top performers, right? So, and that reduces their propensity to leave. While for core performers, because their utility doesn't change, but their equity changes, and they compare their pay for relative to top performers, their internal utility effectively drops in a high CD environment, which means that they are more likely to leave the organization compared to top performers. So the relationship between top performance level of salespeople and turnover is moderated by CD such that a higher CD is associated with lower turnover among top performing salespeople compared to core performers. Now, and the second moderator is regional opportunity of concentration or regional occupational concentration. And the same expected utility theory, if you think about P versus U, is that when there is a lot of opportunities and there are a lot of sales jobs within the catchment area or within the region that these people work, that means top performers already enjoy extensive networks and visibility without increasing the concentration. But the additional or the marginal added probability of receiving a better offer, because there is a diminishing return in receiving in the P, basically receiving an offer. For the high performers start at the higher level already. So if you have a diminishing return, you start at the higher level, every increase in regional concentration marginally increases, but that margin diminishes. But the core performers start at lower, so the diminishing return is steeper for them. So their P increases much higher, which means that the relationship between the performance level of salespeople and turnover is moderated by regional occupation concentration, such that higher regional occupation concentration is associated with lower turnover among top performers as compared to core performers. Now that takes us to the competitive attrition. Now, I don't have a direct hypothesis for competitive attrition because two theories point into different directions. So I only hypothesized the effectively the moderation of regional opportunity effect and compensation dispersion, such that basically higher CD is associated with increasing competitive attrition among top performance salespeople compared to core performers. So higher CD, while reduces their turnover propensity, they are more like, once they decide to leave, they are more likely to join a competitor. And the same effect for ROC, which is, yes, it reduces their propensity to leave the company, but once they decide to leave, they're more likely to join a competitor. Now, and why is that? Is basically both mechanism operates through similar pathway. Extended, basically once you keep them for longer, so the first mechanism that was expected utility theory helps them to stay longer. But then the human capital theory says once they stay longer, basically they increase their industry-specific human capital. Now, they also increase their firm-specific human capital, but once they decide to leave, that firm-specific human capital is already void, right? But the industry-specific human capital is what they would take with them, or their occupation-specific human capital. But the occupation-specific human capital is equally applicable in a competitor versus a non-competitor. But industry-specific human capital is what is applicable for a competitor versus a non-competitor firm when they are deciding. So once you keep them longer, you're increasing their industry-specific human capital, and that industry-specific human capital's utility increases their likelihood to join a competitor because it's going to be helpful working for a competitor. So that's the only difference, and both of these mechanisms go through that industry-specific human capital. Now, this is the whole model, right? So, and all the hypotheses listed here. And you see top performers versus core performers. Effectively, I have one independent variable, which is a dummy variable, top performers versus core performers. Now, I have the low performers in the data set, in the analysis, but I don't hypothesize about them because the theories and mechanisms behind them are different, and it creates a lot of mess. If you ask a question later, I can explain what does that mean. I have two DVs, which is one turnover, and once the turnover happens, I have a competitive attrition. So if turnover equals 1, then we can look at the competitive attrition. So basically a subset of people that move, they will have a competitive attrition. And then you have both moderators on both levels, right? So now the data is effectively, there's a main data set which is called DADS or BTS. Basically, this is the data set that I have been working, God knows since when, but this is a longitudinal data set. It's an administrative data set that includes everyone in France that works and pays tax, right? So if you are paying tax, it's registered there, whether it's private or public, and it's governed by INSEE, which is the French Statistics Office, and it's a longitudinal data. Every year, every person's, based on their social security number, is recorded how many days, in which company, which industry, how much they earned, how many hours they worked, and so on. And this is based on the declaration of firms, and it's matched to the people's tax declaration. Now, however, this longitudinal data, this data is not provided, the comprehensive data that includes everyone is not provided panel-wise, it's provided a discontinuous panels 2 years by 2. So we are not, as a researchers, allowed to match them to get a panel, although you could, but it's illegal. They themselves provide a 1/12 sample of every person who is born in October as a panel. So 1/12 of the comprehensive data comes as a panel, which helps to do longitudinal data analysis. So the sample selection is basically, I use 27 4-digit occupation codes for salespeople, and I use 23-digit manufacturing industry codes, and cross these and find the salespeople who work in manufacturing sectors. And I use organizations that have at least 20 salespeople in them. And manufacturing is because we are trying to look at the B2B sales, and a lot of these theories only apply into B2B, not in B2C. So the final sample includes an unbalanced panel of 200,000 individual year observations from more than 50,000 salespeople working in 9,000 firms, complemented with regional and demographic information. So the dependent variable is an exit event, a dummy variable, whether a salesperson leaves the organization in a given time t or not. And the second one is a competitive attrition, which is the dummy once the exit happens, whether they join a competitor or not. 1, join a competitor, 0, not. Only measures once the exit even happens. The independent variables and moderators are performance level, top, core, and low performers identified using compensation residuals. So that's one thing that I need to discuss. And compensation dispersion, which is the coefficient of variation of compensation in each sales organization. So 20 people who work together in one organization, we take the coefficient of variation in a given time, basically 2003, one compensation variation, coefficient of variation, 2004, 3, 4, 5, etc., etc. And then regional occupational concentration, which is the ratio of salespeople in a region to total salespeople in the country divided by region's surface area. And a bunch of control variables, of which I'm not going to go into details for the time's sake to study. Now, how do I find performance levels? Now, this is a major contention within this type of research that tries to look at performance, because every organization measures the performance of their individuals differently. There's different type of performance levels, behavioral performance, outcome performance, how much they sell, how much profit they generate. So many different ways of measuring performance within one industry, let alone across industries. And this research scope is to look at multiple firms, at multiple organizations. So what is the solution that we came up? We didn't. Other research has come up with. I'm using the first time for salespeople is to look at residuals of the compensation. So basically, I run a OLS regression, log wage, based on a lot of information, individual level variables, firm level variables, region, occupation dummy, industry dummy, year dummy, basically whatever I could find as an observable variable, I plugged it into this wage regression. I control for that, and then take the residual of this wage regression, which is the unexplained part, which is this UIT, and within each organization, 20 people, 30 people working, I rank these residuals and say the top 20% are the top performers, the bottom 20% are low performers, and middle 60% are the core performers, right? And this allows me, the advantage is that cross-firm comparison, I can compare cross-firm, captures multifaceted performance. So this is, the idea is that the compensation reflects all sorts of your performance, because the firm observes your performance, which is reflected in the compensation residual. And then identify rising stars. So basically, if a person who is earning low, but they have been into company 6 months, but the person who earns twice as much, but they have been there for 10 years, the younger or the less tenured person can be identified as rising stars because it controls for their tenure within the organization, right? So that takes me to the model specification and how I model this. Now, I have been through a lot of different iterations of different modelings. I started with the OLS and went through different ways. And after 3 rounds of review, which was always there, the OLS measures, they said, well, your dependent variable is a dummy variable. You shouldn't have used OLS after 3 rounds of review. However, although I had cited 2 similar papers who did the same, and I explained why I'm using OLS, not pure OLS, basically, based and all the endogeneity correction. Effectively, at the 3rd round, they came back and said, no, you did all this, good, fine. You control for endogeneity, all those issues, but you still have to run a probit model or something. So, and because I have 2 dependent variables that are interdependent, I need to let the dependent variables correlate, which led me to use seemingly unrelated bivariate probit model. So, which is a 2-part model. First part estimates the probability of salesperson's exit, and second part estimates the probability of competitive attrition conditional on exit, accounts for potential interdependence between exit decision and subsequent choice to join a competitor. So because these 2 decisions are done jointly, whether to leave the company and whether to join a competitor or not, we had to let these co-vary. So they are interdependent. So, and the seemingly unrelated bivariate probit gives you a correlation coefficient, which tells you how much these 2 dependent variables decisions are dependent. And because now I'm using a probit model, I run into a problem that is called incidental parameter problem in bivariate problem. And that essentially means that if you're running a nonlinear model like probit or logit, things like that, or multinomial logit, if you have too many independent variables, specifically if these too many independent variables are dummy variables, which in my case are the individual fixed effects and firm fixed effects, as well as industry fixed effects, you can imagine how big the estimation matrix becomes. I run into incidental parameter bias, which fixed effects in nonlinear models won't converge, right? The models won't converge, and the maximum likelihood model in these type of models, when you have so many variables, especially dummy variables, the models won't converge. This arises because number of parameters to estimate grows with the sample size, leading to bias estimate of the common parameters. So what did I do is effectively I went back, I ran a separate OLS models for both of them, estimated the fixed effects from the OLS models and brought the fixed effects to the bivariate probit models and plugged them in. So this is the final estimation model. So probability of exit equals 1 if the probit model TP is top performers, low performers, regional occupation, concentration, CD, and all these control variables at the firm, individual firm, industry levels. And this is the fixed effect estimates for exit event from an auxiliary OLS. And this is the fixed effect estimate. This is the individual fixed effect estimate, and this is the firm level fixed effect estimates from auxiliary OLS regression. And this is the second competitive attrition, basically bivariate model, which is the joining a competitor based on whether exit event is 1 equals the probit estimation, right? The phi is the probit model, top performers, low performers, regional occupation concentration, CD, compensation dispersion, individual controls, firm level controls, industry level controls, and the estimation of in the firm fixed effects from an auxiliary regression, which is the beta attrition. And these are the other fixed effects that I could control and the model would converge. All right. Now that takes us to endogeneity issue, which I don't have much time to go into. So far, what I'm running, if I'm not controlling and have just controlled for the fixed effects, I'm not controlling the endogeneity issues that I started with saying, if you don't look at the endogeneity, you don't have a causal inference. Now, what are the endogeneity issues? Endogeneity arises when the independent variable is correlated with the error term in the regression model. This correlation violates the assumption of exogeneity required for unbiased and consistent estimation. So I have 3 different types of endogeneity. First, simultaneity, which means top performer variable likely correlates with exit event due to unobserved individual factors like extroversion, for example. So you are extrovert, you might become a top performer, and at the same time, you might be more likely to leave the organization. Performance levels and compensation dispersion may simultaneously be determined by an unobserved factor like individual effort, right? If you put more effort, you perform better, and you are going to stretch the compensation dispersion of the organization. Another thing is omitted variable bias, lack of control for firm level variables such as organizational culture and control systems. So we don't have measures for that. It's all observational. Competitive culture or outcome-based control system could boost top performers and so on. And then we have also situational factors, which is market dynamics and competitive pressure may induce performance variability and turnover by altering salespeople's operational environment and economic fluctuations in industry, which these fixed effects only control for these ones and partly for this one. Now, what do I do for the rest? I use 2 approaches, which is the control function, right? Basically, for control function, you need an external instrument that is correlated with the exogenous part of the endogenous variable, but it's not correlated with the error term in your regression, right? And based on that, the endogenous variable is regressed on the instrumental variable or other instrumental variables to estimate the predicted value and the residuals. And in the second stage, the residuals from the first stage are included in control function in the main regression alongside the original endogenous variables. So basically, you need an external instrument, which is very difficult to find often because most of the instruments that you find, they themselves are correlated with the error term. And that's the problem. And the second problem is that my endogenous variables, they are themselves binary, right? They're not OLS. And that means instead of running an OLS to get the residuals, I have to run another probit model and estimate the probability from that probit model and predict and measure the difference between prediction and observables and include that as a residual in the second stage of the biprobate model. So, and I did that, and I'm not going to explain what are the instruments and so on, and I included that.
Oh, well, explain.
Sorry? I will come back if there was interest in what are the instruments. Now, having done that, the reviewers came and said, now, three of your instruments are fine, but the third one, because it's a synthetic instruments. Now, synthetic instruments, basically, I use the heteroscedasticity within the control variables to generate a synthetic instrument for the regional occupational concentration. And they said, we don't like this, so you have to do something else. Do a copula endogeneity correction. Now, copula endogeneity correction is basically trying to come up with a latent, modeling the latent relationship between endogenous variables, the endogenous variables, which are the independent variables, and the dependent variable, and basically modeling that. And that's done through copula term. Now, another problem is that the Gaussian copula, which is developed for these methods, are not developed for binary variables on both sides of the regression, right? Now, that led me to go and search, and this is the 2S-COOP model, which is an extension to copula model, which is this paper just published at JMR. And I ended up doing this model, which is basically modeling the residuals of both sides of the regression, dependent variable and independent variable, and modeling the relationship based on the Gaussian copula of the residuals of both of them, which solves some of these problems. Now, effectively, I have danced to every tune that was played, and eventually I did all these things. And there are conditions when you can run 2S-COOP, and that meant that I had to run a simulation with thousands, 1,000 bootstrap simulations to say whether my estimated effect had bias in them or not in the 2S-COOP model, which I had 5 to 10% bias. Now, those are the technical issues, why 2S-COOP is better than the normal Gaussian copula and why it fits my model. And eventually, these are the results, all right? And the results confirm my hypotheses. Now, instead of going into those details, I'm just going to show you the predicted probability of, so this is the predicted probability of turnover on the y-axis, and this is predicted probability of turnover. The red lines are top performers, and the blue lines are core performers. And on the x-axis, you have here compensation dispersion. Here you have regional occupational concentration. So mean is here. Basically, I have estimated the probability of turnover, 1 and 2 standard deviation to the right and to the left of the mean, effectively the marginal effects at those 2 points, and plotted them here. And you can see that when you move 1 or 2 standard deviation to the right from the compensation dispersion, the turnover of probability of top performers go down and core performers goes up, and they become much closer than they are. The same applies for regional occupational concentration. Basically, when you move 1 or 2 standard deviation to the right, the same thing happens. That was about turnover. And here you have the probability of competitive attrition. And you can see that the core performers are higher, right? Always higher. Core performers are more likely to join a competitor. And top performers are less likely. But as compensation dispersion increases, the top performers are more likely to join a competitor, and core performers are less likely, and the gap closes. Now, it doesn't close completely within 2 standard deviation, but the closing of the gap is significant. However, When it comes to regional concentration effect on predicted probability of joining a competitor and competitive attrition, the effect of moderation for top performers is not as strong that can push it up. So to close the gap, so both of them effectively become less likely to join a competitor when the regional occupational concentration increases, but the gap is slightly bigger here as compared to here. But both of the slopes are downwards. So my fifth hypothesis is supported, but with the caveat that actually the direct effect doesn't exist. So the direct effect of regional occupation concentration doesn't increase the probability of joining a competitive, but decreases the gap. All right. So, and finally, this is a contribution of practical implications. So basically, I integrate the compensation design performance difference and regional labor market to explain turnover pattern, highlight the potential destabilizing role of high compensation dispersion, reveal how regional opportunity concentration interacts with compensation to alter retention outcome, introduce a novel approach to identify performance tiers, so basically the residual ranking, and the managerial implication, which basically we say regional occupation concentration interact with your compensation practices and whether you should think about having a centralized or decentralized or sales force spread across the country or within one unit, maybe in Dublin, etc. Reconsider overcompensation of top performers in highly concentrated regions because they are, once they leave, they are going to join a competitor anyways. Balance CD to retain both top and core performers and adapt training versus hiring strategies based on regional concentration and incorporate human capital factors when evaluating salesperson's performances. So that's my presentation. I went slightly over 40 minutes or 45 minutes, but I'm happy to answer any questions that were there. Thank you very much.